Welcome to this Unreal Engine HMI webinar. We are excited to share with you our latest developments. I am Heiko Wenzel, the Director of Industry Management at Epic Games. With me here I have Joe Andresen, our Technical Product Manager for HMI, as well as Vince Stimson, Unreal Technical Artist. Let me give you a short introduction to Epic Games and Unreal Engine and dive into our vision for an automotive platform supporting HMI projects, and then hand it over to Joe with the current status on our embedded developments and the benefits of working with Unreal Engine in that area. I think we have some exciting updates here for you. Before I get started, here's a quick summary of what you can expect from this session. With synthetic realities and autonomous components becoming key aspects of interior design, game engines are on the forefront of creating the new experiences. An Unreal Engine solution platform will allow a wide range of designers contribute to this field like never before. Epic Games has a unique position as a publisher, creator, and software developer in the entertainment and manufacturing industry. At the heart of our engagement sits Unreal Engine that allows us to create our own games like Fortnite, but also enables other game developers to produce their own amazing games. With Epic Online Services making complex services available to every developer, the engine and connected libraries have changed the development and creative landscape. And over the last years, the use of Unreal Engine in the non-gaming industries has gained a lot of traction and success with benchmarking use cases. Fortnite as a development platform has allowed us to create some amazing technology that has its benefits across all of our engagements. Cross-platform use cases with tremendous amount of users and constant updates are not only a gaming achievement, but have key benefits for all of our industry partners. Especially in the last years, with all the restriction and changes we have seen, great adoption in various workflows and have driven changes across industry verticals. The amount of developers and players on this platform represent a unique opportunity for brands and cross-platform IPs. I have mentioned industry verticals, and I would like to give you an overview of what we are developing for. The core of our industry engagements lie with media and entertainment, where we have seen great change happen through virtual production and the rise of LED production stages for visual effects. AEC has been a great place for democratizing the creation of visual experiences, pre-visualization, and digital twins. And on the simulation side, the game engine has become a key player in training AIs or enhancing machine learning. And finally, my personal focus point, the automotive industry has found adoption opportunities across most workflows and departments. It is truly exciting to see how real-time development is providing benefits wherever you look. Our mission with our developer community is found in being part of the overall creative ecosystem. We use our own tools to develop solutions for our games as well as industry partners under the premise of maximum visual fidelity in technology development. In the latter case, we do not work as a service, but only as a support operation. This way, we make sure that if we understand how to succeed, our engine users can succeed as well, and we can all share our developments in an open and connected platform. The last 2 years were a power driver for change and innovation in the technology sector. Aspects like cloud computing that were previously defined as impossible found their way into production in several industries. AI, automation, and machine learning, as well as virtual collaboration, have driven new work philosophies, especially with real-time tools and game engines. And interactive and immersive experiences have gained major attention, especially in the automotive industry. So let's take a deeper look into some of those learnings here. In order to enable the creatives across all industries, Unreal Engine can be downloaded for free. A key aspect to mention is that access to the source code as well as content libraries are included in that philosophy. The goal is to support an ever-growing and sharing creative community that can constantly evolve their applications and build engaging content that feeds the metaverse. Over the last 4 years, we have worked closely with different automotive OEMs to understand the needs for real-time game engine-based solutions. With real-time ray tracing, the fidelity and delivery speed has become a very interesting opportunity, especially in marketing and design efforts. The collaborative features on top of that have been lifesavers in various applications across automotive workflows. The key to accessing this world is, of course, an open and efficient data handling and a pipeline that is consistent throughout the different workflows. Synthetic environments have become a cornerstone for the development of AI-based applications in autonomous vehicles and robotics. Mixed reality applications are becoming key in various design development workflows and are sure to change the interactions between humans and machines. Having access to libraries to create these environments is a key focus for our platform approaches and amplify go-to-market efforts to our clients. For our automotive platform approach, we looked at the current trends in the industry. Unreal Engine can be a key part of the digital thread efforts and can be a substantial element in the definition of the digital twin. The right tools for the visual development platform connecting the needs of a digital twin have not been answered in a democratized way so far, and we can see game engines as a key solution here. In marketing and sales, for example, with direct touchpoints to the client user journey, it is key to provide high fidelity and immersive experiences in real time through an open cross-platform setup. Adding components like environment libraries, materials, AI, and IoT connections can be the deciding factors in speed to market and an overall performance of an open platform setup. Especially if you want to continue the user journey into the car with its embedded systems, we see a combination of integrations play out for the development with UI. Design and manufacturing has been hit by some massive supply chain and collaboration hurdles the last 2 years, as well as a continuous acceleration expectation in how much and different to deliver. From sustainability to customization targets, real-time interaction is key to getting to the best results. Expensive, slow processes are more and more replaced by gamified approaches. Not only can production costs be used in better and more creative ways, but the deployment of the result can happen in the same engine the content was produced, which reduces maintenance efforts and speeds up go-to-market. Another key learning is that this technology makes for a better and more attractive workplace when competing for top talent. A big component in creating content for product visualization and experiences are the environments that the product is presented in. Megascans can help shorten the creation cycle and guarantee great-looking content. Libraries of content are key for HMI applications that integrate well with the surrounding environment. There is some great free, pre-built content in the marketplace that allows you to get up to speed faster than ever before without spending too much time on the creation of other things than the product itself. Various simulation tools have direct relationships or connections to Unreal Engine now that can be used for workflows that need real-world data and sensor connections within and outside of the car. The future of HMI and autonomous cars lie in the smart usage and presentation of that car when users interact with them in real time. A winning factor will be to simplify access and programming needs to those tools and connect all those capabilities with a solid backend framework. With such a vast community adding capabilities, it is always good advice to check what can be built upon for the own targeted solution. Using analytical tools in combination with machine learning drives the next iterations of better experiences, especially with autonomous technology and HMI setups. A smart digital experience will need to use a technology that is easy to maintain, can connect across platforms, and provide persistent quality. Apart from game design helping to build great experiences, streaming content as well as over-the-air updates will be key to get past the limitations of devices and software platforms. Unreal Engine has a lot to offer here, battle-proven on extreme scales. The image fidelity and interactions have been proven in various top-level games, and with pixel streaming, this content is now available at this quality level for all industry verticals. So how do you create an interactive and immersive user journey that connects clients to your brand? All components and target touchpoints will depend on connecting data and service inputs and values with the experiences at the different touchpoints. Foremost, the availability and shareability of the data and experience will drive a consistent experience from the very start of the communication with PR to the web and all the way into the car entertainment. At the center of a successful approach has to be a technology that has the right reach and control points. As the last months have shown, digital is key. And how do you get into all platforms with fast interaction and consistent quality? Streaming and over-the-air updates have shown some amazing benefits in that regard, and now it is time to test the scaling and go-to-market readiness. What we have learned over the last years is that a lot of optimization principles have reached their limit, and it needs bigger changes in the approach of changing workflows within the concept of Industry 4.0 targets. Real-time, collaboration, digital training, and remote support are trends in this year that can be addressed by looking at game philosophy and engines. One of the key focus points here is the integration into HMI workflows as they touch so many of the design decisions and the future value of the products. I mentioned human-machine interfaces several times throughout my talk, and at this point would like to hand it over to Joe to give you the status of Unreal Engine in that space and what we're really excited about. Take it away, Joe.
Thanks, Heiko. Hi, my name's Joe, and I'm a technical product manager for HMI at Epic Games, and I'm going to talk about the tools used for successfully deploying Unreal HMIs into production. We have two OEMs that have announced vehicles with Unreal Engine in their HMI. We have GM with the Hummer and the Lyriq, and we have recently Rivian, who has Unreal HMI in their driver display. So really cool vehicles. I encourage people to go check them out. And I'm going to talk about some tools. So there are three major KPIs or key performance indicators that are important for HMIs in general. And let's go over those really quickly. So we have memory usage. So in an HMI, there are many systems and subsystems aside from the user interface. You've got navigation system, routing system, voice assistant, input management. You got all these different things going on. They all use certain amounts of memory, and it's important to have those systems make sure that they are within their memory budget and operating well. So that's one KPI we're going to talk about. Hitting frame rates. So this is especially important for games, hitting frame rates. But when your HMI is buttery smooth and reacts well and quick to your input, then it's actually safer. And this is very important when having an HMI. Profiling startup time is another important key performance indicator. You can when you sit in your HMI, you expect to have it up and running the moment you sit in your car. And traditionally, HMIs don't normally do that. They have long startup times, and so this is an important KPI for the future. So the first one we're going to talk about is the first tool is Unreal Insights. And so Unreal Insights is used to profile what the engine is doing, and it allows you to see kind of the engine's work over time on all of the different threads, the render thread, the game thread, and so on. And so for HMI, we use this to profile boot time on automotive hardware platforms. There's a wide range of platforms out there, akin to 2014 GPUs all the way up to the most modern graphics and everything in between. So being able to profile how the engine boots up on all of this different hardware is really great. Helps Epic and also helps the OEM see what their project is doing and also what the engine is doing when it initializes. One of the great things about Unreal Engine being open source is that there's no black box. So when you run an Insights trace and then bring up that trace, you'll see the internals of the engine and how long they're taking and what they're doing, so that you can have a complete understanding of the startup sequence. And so we're going to release these slides after the webinar, and I have a link here that takes you to the Unreal Insights documentation, where you can dive in and learn how it works and try it out. So here's a picture of Unreal Insights. You can see the blocks of work there in the view in the center, the different threads, so that the game thread is kind of up there on the top. Here you've got the render thread, and you can see the blocks of work in there, and then on the right you can see what those blocks of work are and how long they're taking, the number of times they're being invoked, and you can see callers and logs and the files that those logs are coming from. So if you have this trace and then the editor source next to it, you can track down exactly the calls and what they're doing and when they're being called and why they're taking a long time. And this really helps you figure out all the things going on. And one of the things, or there's two things that are quite common in HMI development during development, is the shader cache. So during development, as assets are added and content is added, the shader cache gets updated, and the shader cache becomes invalid. So then when you run the project, you see that the shaders not are being compiled instead of just loaded. And so that compilation time, especially on older platforms, takes quite a bit of time at startup. So that when you see that in here, you can find that in Insights. It'll show you, and that's time that can be easily removed for better startup. And then the other one is plugins. So Unreal has a lot of good plugins out there, but for HMIs you don't need all of them. So you can go in and disable plugins, and the plugin modules are initialized at startup, as the engine is starting up. And you can go in and remove that, and you'll be able to see those module startups in here as well. And yeah, get rid of that time. So yeah, go check out Unreal Insights. It's a really cool tool, and yeah, let us know what you think. The next one is memreport. Memreport is a console command, and it is used to track RAM usage. You can also have memreports run in succession and diff those different reports together and find project memory leaks, which is really, really useful. And memreport is actually a bunch of console commands combined, and one of the console commands that's part of a memreport lists all the textures in your project. So you can identify expensive textures or assets that you can later downres or remove. So that's super useful. Here is a link to getting started with debugging and optimizing memory, and it talks about memreport and listing objects and assets and how you can also track those in the editor to figure out where they're being used. So it's really, really great document. I could go check that out. Here is a snippet from a memory report that lists the textures. You can see up here, it tells you what the different pieces of data are, so the maximum allowed size. So this is really cool. So per platform in Unreal Engine, you can tell the editor what the maximum texture size you're going to allow for that platform is. So if you set that up, then when you deploy to a certain platform, you'll never get a texture bigger than that size. It'll cook them down to a certain size. So that's really, really great. You can see here we have a 2K texture, a 1K texture, and another 1K texture. You can see the memory that they're using, and you can see the texture format. So here you can see that this 1K texture is actually the same memory as this 2K texture, but this 1K texture is actually not using a compression format. So that's why it's the same size. That's actually quite interesting to see. So here you can see where this asset is and the name of the asset. And again, you can see the memory it's taking. And in this example, this is not a terrible amount of memory. Where this really comes into play are 4K textures, because 4K textures can take quite a bit of memory, and you can make sure that you don't have those 4K textures in your project. Or if you do, you can make sure that those are intended to be there, and they are intended to be that resolution. So it's very, very useful. Next are the stat commands and show flags. This helps with tracking frame rate and draw calls and a bunch of other things that you can see. And this is really important to be able to do at runtime, because your camera angles have different coverage of different materials during runtime. So, for example, if your visualization is looking at the rim or brakes of a tire, and then your visualization camera pans out and then takes more of the car paint and some of the interior or maybe some of the glass, those different materials are being invoked a different amount in different camera angles. And so, if you have a thin glass transparency material on your automotive glass and you're using a lower end platform, the more that glass comes into the camera, the more expensive that frame will be. And so it's really useful to have the stat commands showing the FPS as you go through your visualizations views to see if any of those materials cause it to drop enough to be an issue. And there are different things you can do. You can substitute some of the more expensive materials for less expensive materials. You can minimize the transparency of your visualization. All of these things are really useful, and actually they can be used by the designer. So the designer will be able to see how his designs are affecting the performance, and the best person to tweak the design is the designer himself. So this is a really great tool for that. Here is a link to getting started with this stat commands and show flags. So the show flags can be used to disable different paths in the renderer. So for example, if you have heavy post-process being used, you can disable post-process entirely and see how that affects your rendering on the mobile platform. And maybe when you find that out, like let's say you disable post-process and all of a sudden you're at like 70 frames per second and you were at 30 before. Well, now you can go into the post-process material and you can see what it's doing and work on isolating exactly what that post-process material does to cost you that much rendering. So it's very, very useful. Yeah, and mobile platforms have draw calls in the hundreds. So being able to track the engine's usage and kind of keep the performance of your Unreal project within the bounds of what the mobile platform is capable, you can actually get quite a bit of mileage out of the engine and still get pretty good visuals. So here's an example of different stat commands. I have scene rendering on the left. I have RHI and memory on the right. And then at the top, I have stat unit and stat FPS. And so you can see here, there's draw calls, mesh draw calls kind of in the bottom left there, the number of lights in a scene. This is the content examples for 427 on my desktop, so I'm using the deferred render, so that's why there's many lights. On the mobile, you wouldn't have the deferred render quite yet, so yeah. The stat FPS and stat unit at the top shows you how long each thread is taking per frame, and depending on which thread is the bottleneck is a clue as to what is the bottleneck in your project. So like I said, like there are different parts of your project, like different views also will affect which, maybe you might have multiple bottlenecks. So a common thing to do is to kind of look away with no objects in the camera and then look at your frame rate. And that's a kind of indicator of like what's possible. So if you look away and there's nothing in your scene and you're at like 90 FPS on a mobile platform, then you move it back to your scene and you see 30 FPS, then there's something in those objects that you need to optimize in order to bring it up to hopefully that 90 FPS, or maybe even a little bit lower. Maybe you could still achieve like really good rendering. So I've kind of gone over the technical kind of ways of looking at performance, memory, and these things that a designer could learn to use and be empowered to increase the performance of their design. Next up, we're going to have Vince, who's a technical artist, who's going to show you a visual way of achieving good high fidelity visuals while still maintaining performance. So thank you.
Thanks, Joe. Hi, everybody. My name is Vince. I'm a technical artist on the HMI team. I've been working alongside the HMI team and our OEMs for the past year and a half to develop techniques for rendering and pipelines which deliver high quality visuals on the HMI systems embedded in vehicles. Okay, so the first thing I wanted to talk about today is the mesh quality that we need to achieve kind of the highest quality rendering on mobile devices or mobile hardware. So This project you've probably seen before. This was running on a Galaxy Tab S6, which is equivalent to the 8155 chip. And it's really great quality for what you'd normally get on a mobile device, right? So you can see that the quality of the reflections is really great. Everything's super smooth. There's not many compromises to the visual quality here. Now, one of the things that we did to achieve that was to have a high resolution mesh. So traditionally, when we think about lower powered hardware, we kind of strip everything down to the lowest common denominator. But in our case, we were able to achieve a vehicle that has around 500,000 vertices and still render completely at 60 FPS, no problem at all. So let's take a look at one of these pieces here. If I turn on the wireframe, you kind of get an idea of the density of the mesh here. It is pretty dense, but it allows us a couple things. For one, we're not using any normal maps in this material here. Because we have such a high density and the asset which was imported was a high quality one, we can maintain enough reflection quality in the surface that we don't need a texture there. So that saves us on a texture, it saves us on instruction counts, all sorts of good stuff. Now another thing that we can do is use the verts color to define different portions of the car. So in this case, what we're doing is we're using the green channel to define the panel gaps. Now in the material itself, we have a lookup for the green channel here, and that's being distributed to a bunch of different areas to mask things like color and roughness and specular and all these other things. And essentially what we're trying to do here is make the panel gaps just like jet black. The reason we do that is because that's how it kind of looks in real life, and since we have all these vertices, we have a lot of range to work with, so the gradient fall off is actually pretty it's pretty well established here. And what that allows us to do is at a distance like this, we have a little bit more meat to use for anti-aliasing purposes. So if it was just an on-off, like a binary thing, you wouldn't have as many options further away, but because it's a nice gradient fall off, it looks really good. So we have this high density mesh. It's allowing us to see verts colors. That's really cool. We don't use normal maps. That's awesome. So it's just a great way to do things. And I think going forward, this is kind of like the peak of what you really need, which is kind of funny to say, but really you could take this mesh, this entire blueprint here, and throw it into a ray tracing, and you could have marketing stills that look really, really good. I mean, we've done this in the past, and we were really surprised with how well a mobile asset, finger quotes, holds up compared to, some of the higher end rendering that we're doing at Epic. So we can also kind of go the other way. If we really wanted to, we could take this high density mesh. So this is 55,000 triangles, our vertices, and let's take this down to 15% of its initial size, and we'll see that this tool does a great job at reducing the count. So you might not even notice the difference here. If you look real close, you'll see in the rounded areas there's a little bit of faceting, but that's because we've greatly reduced our resolution here. But what did not change was the surface normal quality. It's completely all there still, which is fantastic. Even if you go down to something insane like 1%, you'll start to notice some stuff, but if you were far away, you might not notice. So as LOD generation for sure, but also if you happen to be hitting a memory ceiling and you need to greatly reduce your triangle count on your meshes to save on memory, this tool is going to make it really easy for you to do that. Now, if you're going to be optimizing a mesh down to this level, and if you're using hardware that is just not very strong with 3D rendering, I'd probably recommend not defining the panel gaps in the mesh itself. You'll probably be better off with a texture lookup that defines the gap with the normal map and an ambient occlusion. The reason being that if you have lower end hardware, you probably have a lower end, or rather a lower density screen pixel density. So a MIP texture can do a lot more for you than a panel gap defined by the geo here. This is kind of a worst case scenario for aliasing. So on a low-end device, it's just going to be a lot of work to make this look nice. But texture would make it pretty much non-existent. So once we have kind of a nice base for lighting, we can start throwing this into a scene and start looking like, or start looking into what it's going to take to make this look the way it does here. Now, there are lots and lots of different ways to light inside of Unreal. There's many tools, many effects that we can use. When we're rendering on mobile hardware, we have to be very cognizant of what sort of rendering preview we're looking at. So before we get started, the first thing that you'll want to do if you're lighting for mobile devices is go into your settings and then go to your preview rendering level and choose Android ES 3.1. So essentially what this is doing is showing you what the scene will look like when it's rendering in OpenGL. Now, there are a couple differences between the main desktop render and OpenGL. We lose out on some things like screen space reflections, and there are more and more effects coming into the works all the time. So if you're jumping over to something, say like Vulkan, you can get things like, or even OpenGL is starting to have things like ambient occlusion, runtime, screen space, ambient occlusion, and things like that. But for now, we're just talking about having this essentially very simple OpenGL with no essentially no extra effects available to us. But that doesn't mean that we are going to lack in quality. What that means is that we just have to have a little bit more forethought into the way that we light things and the materials and the relationships between the two. So in this scene, I have just a static light. So if you're familiar with Unreal, you'll know that lights have static, stationary, and mobile settings. To achieve the best looking lights inside of OpenGL, you are going to want to use essentially pre-calculated things like shadows. Now, all the lights inside of Unreal can choose to use static, which is going to do that. Through Light Mask, what we can do is build the lights, and that's what's happening here. So I have a static light, and this is built in a lower quality level, which is why you're seeing some of the shading here. But this is giving you the impression of what it's going to look like when you build for real. Now, this is sort of the worst case scenario when it comes to lighting a car for the mobile renderer, because what we have here is one light with a very strong influence on one side of the car. So the trickiest thing here with rendering materials in Unreal is that typically we only have one sphere reflection capture for a hero vehicle like this. Traditional games and stuff, we can use lots of these, and we can move smaller ones to isolated locations for local reflections, but in this case we're only going to utilize one. It's cheaper, and we can still achieve the effects that we want. So we can see here that the car is reacting really nicely to the light here, and essentially what I did is I placed this light in the scene and I built my scene. I have my reflection capture, and it caught the specular. So we can see here that we have this clear coat paint, and it's reacting really nicely. Same with the windows, everything's looking like it should. Now, one of the reasons why we've used this in the past is because it's really easy. You just place your lights in the scene to create a studio lighting environment, and you bake, and everything is going to go into textures. And of course, there are many different courses on density and all sorts of things that utilize light mask to its fullest extent. And that's what we've done in previous projects. And what we've also seen is that HMI is starting to trend towards dynamic. So we can have a vehicle like this statically lit, which means it can't move. It's just going to sit here and look pretty, which is great. But what if we want our car to move? What if we want it to rotate? What if we want things to open and close? We expect that an HMI is going to have some sort of animation and dynamics to it. So in this case, achieving the best quality visuals for a static object is lighting things the traditional way. Now, if we want to light things that look pretty much identical but are fully dynamic, we can take a look at another scene here. And we can see here that the vehicle is doing pretty much identical things here. It's reacting a little bit differently, but that's because we have a different lighting environment here. If we take a look at the right here, we can see that I have a skylight. It has a pre-assigned cube map, and if I open that up, we can see it looks very similar to what you would imagine the skylight or the capture of that other scene. So we have a rectangle light, and this is it's curved because of the projection of the texture here, but we also have the ground, and it's really, really simple. This was calculated outside of Unreal Engine, inside of Arnold and Maya, and it's really easy to do. All you have to do is capture an HDRI. You can import it in. You could even use photo-based lighting, but if you want to do things all in CG, you're not exclusively stuck with using Unreal Engine stuff, although we recommend doing that, and we're going to talk about that next. But it was really simple to import. I just throw it on these two elements, the skylight and the sphere reflection capture as a specified cube map, and I get a nice looking car. Now, something that you might have caught already is that I have shadows here still. So these are dynamic lights. I haven't built anything inside of the light mass, so where are these coming from? And these are coming from Arnold as well. So essentially what you can do is have a scene in Maya which has your lighting elements and your vehicle in place, and essentially you select each one of these panels, and what you can do is go into Arnold and you can go into the utilities and then render selection to texture. Now essentially what that's going to do is give you a high dynamic range, 32-bit grayscale, or even color if you're using colored lights, texture, which then you can assign to the materials inside of here in Unreal. So if I take a look at something here, we can take a look at the floor. We can see that I have a texture here. It was pre-calculated in Arnold. It's pretty small, it's 512. And that essentially is creating our shadows for us. And pretty much all the pieces in this car are receiving the same thing. So we've achieved basically, we've done all the work of light mass outside of Unreal. So that's not really useful by itself, but what's really cool here is that I can select my mesh and I can start to, start to, if I can grab the right thing, I can wiggle it. So with a static mesh, traditionally you cannot do this inside of Unreal. There are some ways to enable static built stuff to move. But in this case, we have a little bit more flexibility with what the content is. So what I'm doing right now is I'm rotating a vehicle that has pre-calculated shadows and directions. So if I rotate this thing fully around, you're going to notice that things look really strange. And that's because the lighting in Unreal, the additive part of our lighting, is coming from one direction and it's not rotating with the vehicle. Now in theory what you could do is you could rotate things along and have your vehicle rotate, but then you have the lighting, it's rotating in the rest of the scene as well. So generally speaking, this is, like I said, the worst case scenario. I wouldn't expect to want to rotate this car more than a few degrees in either direction, because then the relationship between the additive and the subtractive portions just mismatch and it doesn't look that great. The point of this all is to point out that you can do the offline rendering of shadows and textures and everything and bring it into Unreal and achieve something very similar to light mass with a couple of components. Now, something that's kind of more in line with what we'd see is something like this. So if you look over here to the right, same exact setup. We have a skylight and we have a sphere reflection capture, but the HDRI is different. So if you look at this, it kind of looks like a soup of weird shapes and everything. This was actually generated in Unreal itself, and I'll show you how I do that in just a moment. But this is how things have made lighting in Unreal and the iteration time really, really low. And each one of these tiny little spots of light and shapes has a purpose. It's contributing to a car. Actually, not this vehicle is a separate vehicle, but that's the idea. So I'm taking a look at this car here, and it's holding up really well. And pretty much in every angle, because that's how it was look dev. And there's not a whole lot that you could point out that's wrong with the rendering here. And this is being achieved with really simple setup, and the rendering cost is really, really low. So this is the scenario that we're seeing a lot inside of HMIs today. You can achieve high quality rendering, high quality lighting with very simple costs and assembly. So same as before, I can grab this car, and because the lighting's a little bit more even, things hold up better from pretty much any direction. Okay, so now what we're looking at is the scene that I used to generate that HDRI. So all those panels that we saw in the reflection capture before are now represented in 3D space. Essentially, this is the same blueprint that's been duplicated a bunch all over the place. I added in a couple parameters to change the emissive, so the brightness, or the power. That would be if it's a circle, how much of a circle it is, or if it's a square, all these other things. It also has things to like change the color. And you can see that starting to show up in this mesh immediately. So the mechanism to do that is essentially a scene capture cube, which I've dropped into the level. It's basically in the center of the vehicle, which is where you want it. And it's got hidden actors, so I don't want the car to show up in its own reflection, so I've hidden those actors. And this is rendering a scene color HDR in 32-bit. And what's really cool about this workflow is that I can see my preview live, so the instant I move something, I can see that represented on the mesh. What I'll typically do is have a couple cameras that I can view through and maybe a separate window where I'm moving around. And then when I'm happy with something, what I can do is right click on the live render target and create a static texture. So before I do that, what I'll do is I'll just start from the beginning. So we have our key light here. This is going to be driving the highlights from our main view, which is kind of this 1/3 view here. And let's go ahead and, yeah, we can see that updating live. I can create a static texture. And at the very bottom of my list, I've created multiples, as you can see. I now have my HDRI. So I can look closely, I can see it's being rendered right here. And there's some artifact going up on here. That's not an actual artifact. What that is a duplicate vehicle with its own lighting setup from before. So basically what I can do is work down here. I could double mouse click. So if you hold both your left and right mouse, you move up and down. You can see the scene is really easy to navigate. And then I just refresh my texture. So on my skylight, I refresh my texture, and I do it here on my this one right here, and I just build my reflections. And now I have a dramatically different lighting scheme. So this back and forth between taking kind of like a preview view down here, getting somewhere where you like, adding something, it's extremely fast. So I've just made a totally new lighting scheme. I can see what that looks like inside of my material here. Right click, create static texture, move on up. Rebuild. Now, I don't know about you, but that is a pretty short iteration time. And generally speaking, I don't make minute changes down here and then instantly load them. I'll work for a little while and then apply something once I'm happy with it. But yeah, essentially what you're doing is you're creating an HDR really quickly, and you're seeing what it's going to look like on the exact vehicle with the exact same lighting scheme that you'll see on device. Okay, so I just wanted to cover one of these topics a little bit more detail really quickly here. So like I mentioned before, this lighting environment here has pre-calculated shadows, which were all generated inside of Maya using Arnold. Now what that means is that every single one of these meshes has an individual texture that was built with a lighting scheme that basically matches what we see here. Now, if you wanted to create a shadow map that applies to more lighting scenarios, what you could do is not have just a single light, but you could do something which essentially is just a skylight or a soft dome. Now, before we jump into Maya, I just want to cover how this is being achieved here. Essentially, I have a clear coat material that's using ambient occlusion. And that ambient occlusion is not only being applied to the ambient occlusion here, but in this case it's also masking the clear coat, and that can help kind of reduce some of the bounce from the floor, and generally just mask some of the specular in some of these areas here. Ambient occlusion won't do it all by itself. Highly glossy materials need to also mask some of the specular, so you can fine tune that with that texture. Now to generate that texture, I have something just like this, which is basically just a sky dome with all the default settings, and when I render out it looks something like this. And you can see that these shadows are perhaps a little bit stronger than you'd see in a general AO. There's a little bit more directionality, right? It's not just things being close to things, it's also kind of got volume to it, and that's really important. So things like the interior will ambient occlusion might not just be enough. It might be best having something like a skylight, or even if you have very even rectangle lights, that would work as well. Last thing I want to cover though is, let's say you have a lighting environment like this where it's very simple, it's non-directional. What you could do is have that lighting be applied to a color channel inside of the vertex color instead of just being a texture. If it's something that you know you're going to use quite often, you'd benefit from having it inside of the vertex color where you can use it all the time. And then if you have some very specific lighting scenario where you have a strong directional light, that could be offset with a texture instead. But for like general lighting, it might be best to transfer the bake of these textures into the vertex color, and specifically for a lighting environment which is a little bit more even, something like this would totally suffice. So basically offload those textures, all those draw calls, push it all into the mesh. And that's it for me. Thanks for joining us today.